Hello friends, in my previous video I had completed practice set 2.1. Now in this video I will explain all examples from practice set 2.2. Now let us start. First, use of properties of parallel lines. Let us prove a property of a triangle using the property of angles made by a transversal of parallel lines. Now see this where what is that property? The sum of measures of all angles of a triangle is 180. Now we will prove this property by using the transversal of parallel lines. Okay, now let us start. Theorem. The sum of measures of all angles of a triangle is 180 degree. Given triangle ABC is any triangle. See this here. ABC is any triangle. To prove measure of angle ABC plus measure of angle ACB plus measure of angle BAC is equals to 180. Construction. Draw a line parallel to segment BC and passing through A. On the line, take points P and Q such that P dash A dash Q means A lies between P and Q. Now see this figure. We have drawn the line PQ which is parallel to BC. Line PQ is a parallel to BC and segment AB is a transversal. Angle ABC, angle ABC is a congruent to angle PAB or angle ABC is equals to angle PAB. These are the alternate angles. This is the first. Next, line PQ is parallel to line BC. Segment AC is the transversal. Again, we have the angle ACB is equals to angle QAC. These are again alternate angles and therefore from 1 and 2. If we add their left hand sides means what? Measure of angle ABC plus measure of angle ACB is equals to measure of angle PAB plus measure of angle QAC. Adding angle BAC to both sides of this third statement, then what you will get? That is angle ABC plus angle ACB plus angle BAC is equals to angle PAB plus angle QAC plus angle BAC. Now the sum of the measures of these angles, that is the angle PAB plus angle BAC, PAB plus BAC plus angle QAC. We have rearranged these angles. Now sum of these two angles, that is a PAB plus BAC. PAB plus BAC is equals to measure of angle PAC plus this QAC, and hence these are the linear angles. Their sum is equals to 180 and hence the measure of angle ABC plus measure of angle ACB plus measure of angle BAC is equals to 180. That is sum of measures of all angles of triangles is 180. Okay, and this we have proved. Now next, test for parallel lines. First, whether given two lines are parallel or not can be decided by examining the angles formed by a transversal of the lines. Now in this figure, line Q is a parallel to line R and P is their transversal. Line P is their transversal. First, if the interior angles on the same side of a transversal are supplementary, then the lines are parallel. Interior angles. Here, the interior angle D and E, they are on the same side of this transversal P. And angle C and angle F, they are the interior angles on the same side of the transversal. If their sum is 180, then the lines are parallel. Next, if one of the pairs of alternate angles is congruent, then the lines are parallel. Now see this again, line Q and R. P is their transversal. One pair means what? The measure of angle C is equals to this measure of angle E. If both are same, then line Q is a parallel to line R. Next, if one pair of corresponding angle is congruent, then the lines are parallel. Means what? If the measure of angle A is equals to measure of angle E, then the lines are parallel. Now, interior angles test. If the interior angles formed by a transversal of two distinct lines are supplementary, then the two lines are parallel. Okay. Now, see this the figure. Line XY is transversal of line AB and line CD. Measure of angle BPQ, measure of angle BPQ plus measure of angle PQD. PQD is equals to 180 to prove that line AB is a parallel to line CD. I will prove this. First, to prove that line AB is a parallel to line CD, we are going to give an indirect proof. Let us suppose that the statement to be proved is wrong. Means what? Line AB is not parallel to line CD. Then what will happen? That is, we assume line AB and line CD are not parallel. Means line AB and line CD intersect at point D. So, triangle PQT is formed. Triangle PQT is formed. Now, the measure of angle TPQ, measure of angle TPQ plus measure of angle PQT plus measure of angle PTQ is equals to 180 sum of angles of triangle. Now next, but angle TPQ, angle TPQ plus angle PQT is equals to 180 degree. This we have given. That is, the sum of two angles of the triangle is 180. That is the measure of this angle, and this is a 180. But the sum of three angles of a triangle is 180. That is, then the measure of angle PTQ, that must be 0. Okay. Therefore, line PT and line QT means line AB and line CD are not distinct lines. But we are given that line AB and line CD are distinct lines. Therefore, we arrive at a contradiction. Therefore, our assumption is wrong. Hence, line AB and line CD are parallel. Thus, it is proved that if the interior angles formed by a transversal are supplementary, then the lines are parallel. This property is called interior angles test of parallel lines. Next, alternate angle test. If a pair of alternate angles formed by a transversal of two lines is congruent, then the two lines are parallel. Given line N is a transversal of line L and line M. See this here. This is a line N is a transversal of line L and line M. Angle A and angle B is a congruent pair of alternate angles. Angle A and angle B are congruent pair of alternate angles. That is, angle A is equals to angle B. Measure of angle A is equals to measure of angle B. To prove line L is parallel to line M. Now proof, measure of angle A plus measure of angle C is equals to 180. Measure of angle A plus C is equals to 180. These angles are linear pair. Angle A is equals to angle B. This we have given. Therefore, measure of angle B plus measure of angle C is equals to 180. Here we are replacing the angle A by B, and that's why measure of angle B plus measure of angle C is equals to 180. Now next, but angle B and angle C are interior angles on the same side of the transversal, and therefore line L is a parallel to line M, okay, by using the interior angle test, and therefore this property is called the alternate angle test of parallel lines. We prove this property by using the interior angle test. Corresponding angles test. Theorem. If a pair of corresponding angles formed by a transversal of two lines is congruent, then the two lines are parallel. Line N is transversal of line L and line M. Angle A and angle B is a congruent pair of corresponding angles. A and B is a congruent pair of corresponding angles. That is, measure of angle A is equals to measure of angle B. To prove line L is parallel to line M. Now see this here proof. Again, the measure of angle A plus measure of angle C is equals to 180 angles in linear pair. But we have given that is a measure of angle A is equals to measure of angle B. This is given. And hence here again we are replacing the measure of angle A by B, and hence measure of angle B plus measure of angle C is equals to 180. This is a pair of interior angles on the same side of the transversal is supplementary. Means what? Measure of angle B plus C is equals to 180. Therefore, line L is a parallel to line M by interior angle test, and hence this property is called the corresponding angle test of parallel lines. Okay. Now next, corollary. If a line is perpendicular to two lines in a plane, then the two lines are parallel to each other. Here the line N is perpendicular to line L and line M, and that's why here we want to prove that line L is parallel to line M. Line L is parallel to line M. Now proof. Line N is perpendicular to line L and line N is perpendicular to line M. This is given. Now here the measure of angle A is equals to measure of angle C is equals to 180, as the line N is perpendicular to both the lines. Angle A and angle C are corresponding angles formed by transversal N of line L and line M, and therefore line L is parallel to line M by the corresponding angle test. Next corollary, if two lines in a plane are parallel to a third line in the plane, then those two lines are parallel to each other. Now we'll prove this. See this here. In this figure, line CD is a parallel to line AB. Line EF is a parallel to line AB. Therefore, these two lines, which are the two lines? Line CD and the line EF are parallel to AB. It means that line CD and the EF are also parallel to each other. See this here. The line AB, CD and EF are coplanar, means they are in the same plane, such that line AB is a parallel to line CD and again line this AB is a parallel to EF. Line PT, this line PT is the transversal intersecting line AB, CD, EF at points Q, R, S respectively. To prove that line CD is a parallel to line EF, proof. Line AB is a parallel to line CD and line PT is their transversal. Line AB is a parallel to line CD and this PT is their transversal. Therefore, measure of angle, that is the angle angle PQB is a congruent to angle QRD. QRD. These are the corresponding angles. That's the first statement. Next, line AB is a parallel to EF. Okay, line AB is a parallel to EF and PT is their transversal. And therefore, again here, angle, measure of angle, that is the angle PQB. This PQB is a congruent to angle QSF. Again, these are the corresponding angles. Okay. And therefore, from 1 and 2. Okay. That is a PQB is a congruent to QRD. PQB is again congruent to QSF. It means that the angle QRD is a congruent to angle QSF. Okay. Now see this here. These two angles are congruent. And hence, as these two angles are congruent, therefore, line PT is a transversal of line CD. And here, line CD is a parallel to line EF by the corresponding angle test for parallel lines. And in this way, we have completed all the solved examples and theorems. Now let us start practice set 2.2. First example, in the figure, measure of angle, this y is equals to 108 degree, x is equals to 71 degree. Are the line M and N parallel? Justify. Now the solution, here y is equals to 108 degree, x is equals to 71 degree. This is given. X plus y is equals to 108 plus 71 and that's equals to 179 degree. X plus y is not equals to 180. Line M is not parallel to line N as it does not satisfy interior angle test for parallel lines. Next, in the figure, if angle A is a congruent to angle B, then prove that line L is parallel to line M. It's clear that these are the exterior alternate angles. Okay. Now proof. Consider angle C as shown in the figure. Angle A is a congruent to angle B. This is given. Angle A is congruent to angle B. Angle A is a congruent to angle C. They are vertically opposite angles. Therefore, angle B is a congruent to angle C. Angle B is a congruent to angle C from 1 and 2. And therefore, line L is parallel to line M. by the corresponding angle test for parallel lines. In the figure, angle A is congruent to angle B, angle X is congruent to angle Y. Prove that line L is parallel to line N. Now proof. Angle A and angle B are the corresponding angles formed by lines L and M, and K is their transversal. Angle A is congruent to angle B, this is given, and therefore line L is parallel to line M by the corresponding angle test for parallel lines. This is the first one. Next, angle X and angle Y are the alternate angles formed by the lines M and N. X and Y, these are the alternate angles, and a transversal. Okay, and their measures are equal. That is, angle X is congruent to angle Y, and hence line M is parallel to line N by alternate angle test for parallel lines. This is second one. Now in first case, line L is parallel to line M, and in second case, line M is parallel to line N. Means what? Here line M is common, and therefore line L is parallel to line N, and this we have proved. Therefore from 1 and 2, line M is parallel to both the lines, line L as well as line N. It means that line L is parallel to line N. Okay, and therefore line L is parallel to line N. Now next, in the figure, if ray BA is parallel to ray DE, that is, BA is parallel to ray DE, measure of angle C is equals to 50 degree, that is the measure of angle BCD is 50 degree. Measure of angle D is equals to 100. Find the measure of angle ABC. We want to find out measure of angle ABC. And here we have given hint. What is that hint? Draw a line passing through point C and parallel to the line AB. Okay. Draw the line passing through the point C and that's parallel to AB. Solution. Draw a line XY passing through C. Okay. Point C and parallel to AB. This is the XY parallel to AB. Ray D is a parallel to ray BA. Ray D is a parallel to ray BA. This is given. Ray BA and the line XY is a parallel. That is our construction. Ray D is a parallel to ray BA and is parallel to line XY. Okay, this is the first one. As these two are parallel, BA is parallel to XY. It means that all these three, that is a ray DE, is parallel to ray BA, is parallel to line XY. This is the first one. Next, measure of angle EDC is equals to 100 degree. EDC is equals to 100 degree. This is given. Ray D is a parallel to ray XY. D is a parallel to ray XY. And line DC is their transversal. This is the transversal. Okay. And therefore measure of angle EDC, measure of angle EDC is congruent to measure of angle DCX. DCX. That is the angle EDC is congruent to angle DCX. These are the alternate angles as they are parallel. Okay, and therefore their measures are equal. That is a measure of angle EDC is equals to measure of angle DCX. Okay, and therefore measure of angle DCX is also 100 degree. Okay, now see this here. The measure of angle DCX is equals to 100 degree. Next, measure of angle DCB, measure of angle DCB plus measure of angle BCXB DCX is equals to measure of angle DCX. Okay, that is the sum of the measures of angles addition postulate. But what about the measure of angle DCB? Measure of angle DCB is 50 degree. We have given it. The measure of angle DCB is 50 degree plus measure of angle BCX is equals to 100 degree, and therefore measure of angle BCX is equals to 100 minus 50 degree, and therefore measure of angle BCX is equals to 50 degree. Measure of angle BCX is also 50 degree. This is the second one. Next, ray BA is a parallel to line XY, okay, and BC is their transversal, okay. Now the measure of angle ABC plus measure of angle BCX is equals to 180. They are the interior angles, okay. But we know the measure of angle BCX, that's equals to 50, and therefore the measure of angle ABC plus 50 degree is equals to 180, and hence measure of angle ABC is equals to 180 degree minus 50 degree, and that's equals to, and measure of angle ABC is equals to 130 degree, and hence we have calculated the measure of angle ABC, and that's equals to 130 degree. Now next, in the figure, ray AE is parallel to ray BD. Ray AF is the bisector of angle EAB, and ray BC is the bisector of angle ABD. Prove that line AF is a parallel to line BC. Now see this here. In the figure, ray AE, this is the ray AE, is parallel to ray BD. These two rays are parallel. Ray AF is the bisector of angle EAB, and ray BC is the bisector of angle DBA. What we want to prove that? We want to prove that the line AF is a parallel to line BC. Now see this here. Ray AE is a parallel to ray BD. This is given. Line AB is their transversal. Therefore, measure of angle, that is angle EAB, is a congruent to angle ABD. These are the alternate angles. Okay. Next, therefore their measures are equal. That is measure of angle EAB is equals to measure of angle EAB is equals to measure of angle ABD. Multiplying both sides by 1 upon 2, we get, that is 1 upon 2. Measure of angle AB is equals to 1 upon 2 measure of angle ABD. If we take their half, then what we will get? Okay, as AF is their bisector, therefore FAB is equals to 1 upon 2 measure of angle EAB. This is the second one, as ray AF is the bisector of angle EAB. Okay. Next, measure of angle ABC is equals to 1 upon 2 measure of angle ABD. Okay, as ray BC is bisect bisector of the angle ABD, and therefore the measure of angle FAB is equals to measure of angle ABC. As the measures of these two angles are same, their half are also same. Means what? Measure of angle FAB is equals to measure of angle ABC. Now the angle FAB and angle ABC, these are the alternate angles for the line AF and BC whose transversal is AB. Okay, their measures are equal, and hence by alternate angle test, ray AF is a parallel to ray BC. Now see this here. Okay, as therefore the measure of angle FAB is a congruent to measure of angle ABC. And therefore line AF is a parallel to line BC. Alternate angle test for parallel lines. Now next, a transversal EF of line AB and CD intersect the lines at P and Q respectively. See this here. The EF is a transversal of the line AB and the line CD. It intersect at the point P and Q. Okay. Ray PR and the ray QS. Ray PR and the ray QS are parallel and bisectors of angle PPQ and angle PQC. They are parallel. Ray PR and QS, these two rays are parallel as well as they are the bisector of angle BPQ and angle PQC. Then prove that line AB is a parallel to line CD. Okay. Ray PR is a parallel to ray QS. This ray PR is parallel to QS and line PQ is their transversal. Okay. Therefore, angle RPQ is a congruent to angle PQS. Okay, RPQ, this and these two angles are congruent. These are the alternate angles as these two lines are parallel. PQ is their transversal. Therefore, by alternate angle test, these two angles are congruent. Next, therefore, their measures are equal. Therefore, measure of angle RPQ is equals to measure of angle PQS. Okay. Now, as ray PR bisect BPQ, ray PR bisect ray BPQ, and therefore measure of angle RPQ is equals to 1 upon 2 measure of angle BPQ. Okay. Also, measure of angle PQS is equals to 1 upon 2 measure of angle PQC. See this here. The measure of angle PQS is equals to 1 upon 2 measure of angle PQS as ray QS bisect angle PQC. Okay. But we know that the measures of these two angles are equal. That is RPQ is equals to PQS. And therefore, their halves are also equal. And we write here 1 upon 2 measure of angle BPQ is equals to 1 upon 2 measure of angle PQC. Half get cancel on both sides and therefore you will get here measure of angle BPQ, measure of angle BPQ is equals to measure of angle PQC. These are the alternate angles for the two lines AB and CD. Their transversal is EF. Okay. As they have equal measures, therefore, the angle BPQ is a congruent to angle PQC. Okay. Therefore, line AB is a parallel to line CD. Alternate angle test for parallel lines. And in this way, we have proved line AB is a parallel to line CD. And at the same time, we have completed here practice set 2.2. Now we will see in the next video. Till then, goodbye.